So guys, let's start. Again, let's start. So we are in the middle of our course. We already know how to use all general ideas from LaTeX. We already know how to add text, figures, code, tables, how to structure a document, how to refer to the structure, and how to make presentations. And now we are going to a slightly advanced topic. It will be advanced because it's not so commonly used, but still it's used a lot for typography ideas. It's the TeX library, and it's a very huge library with a manual about more than 1,000 pages. I don't read it through, but still it's massive. Obviously, we will talk about only part of it. Well, but still we will talk. But at the beginning, I want to clarify about the task I'll give you yesterday. This task of implementing some template. So the deadline of this task will be a week after the course ends, about 27th of January, so you will have a week more for complete this task. And I remind you that this task is pretty arbitrary. If you want to make it just for check, you can use a simple template of some scientific journals. Usually they are quite simple. But if you want to have some challenge and the most important to ask us questions if you don't understand something and make something that you will use in your usual life, you can make more complex template, but it's up to you. And I was reminded that I need to clarify the formal stuff about course. So the formal stuff, the attendance in 4 or 5 lessons, as CV said, and then it's just uploading the results of your in-class task and this homework to the canvas. Nothing all, nothing less. We will not judge if it's something poorly, because the main goal for our course is to teach you LaTeX, not to create you such formal problems because of assignments. Okay, just a moment, I will double check. Let's remind about technical stuff. And today we will use, the main topic for today will be TeX, and at the end we will we'll talk a little about typography and about font settings. So again, agreements, you also know about footnotes. Who already saw any of the lectures that we post for home use? One of you, yeah. 2, great. So please don't hesitate, see it, because there are footnotes with useful information practically in every page. It's maybe a whole new world of LaTeX is waiting for you in these footnotes. Okay, agreements, exercise, all of this you know, and today's special thanks is for Anna Pavlovcheva, who helped me with non-technical stuff about fonts, because it's also typography, it's about art and not about sounds, and she helped me. And also I remind you that today, as always, we have 4 people to help you. First it's me, secondly it's Piotr Borisovets, then it's Pavel Kuzmin, and Anna Litvin. And in the break, please go to Peter and he will mark your attendance. Don't forget it. And today is lecture will be mostly held not by me, but by Anna. She used TeX more frequently than me, and I think it have much more expertise in this topic. So I'll give her the word.
Good afternoon, dear students. I'm glad to talk to you today. I came here just as TA, but I wanted to add spiciness in my life, so I asked Anton whether I can tell some parts of the course, and he gave me this part about TeX. I need my clicker, yes? Under the head, okay. Let's go into TeX, right? We will have several parts. First is introduction. This is some smart quote probably from the founder of the tech, right? And TeX actually is not a drawing program. You will see that TeX is pretty hard to work with, but we will find some cases where you can use it for your good, let's say. Okay, so on the slide, you can see the first example how we can use TeX inside LaTeX document. We can draw something inside the text. Here we can see the code that was used to produce this orange circle. Let's look at this code. First of all, we have TeX command. This command tells that we want to insert kind of in place graphics in one line, short graphics into the text. For bigger graphics, we will have another command. What we have inside TeX command, we want to draw some figure, to fill it with color. That's why we tell fill, orange color. We give the coordinates of the circle and the size of the circle. Actually, in this example, the coordinates are kind of not needed because the circle is just placed inside the text. These coordinates are kind of relative inside the picture. So if you have just one thing, you don't need these relative coordinates. But this is the simplest example. Y-X and radius. I hope this example is clear. Let's go further. Let's talk about why you want or probably don't want to use TeX. First of all, TeX is very hard, and probably to make complex pictures, you will use other software. If you want to visualize your experimental data, you don't need TeX. And also in TeX, like in LaTeX, it is not, I forgot how to, what you see is what you get. So you write and then you see some results on the picture, but you cannot move parts inside the picture like you can in, for example, Google Word, or I don't know, where do you create your pictures? Miro or some other software. I believe it's something like Matplotlib and Python, where you can write some code, you see the result, and you need to guess what to change the picture. So it's not very easy to use. However, TeX still can be used. You can use it for simple graphics. What else? So we will show you several examples when it's very easy to use TeX, so you can kind of incorporate it right away and understood the syntaxes very easily. Also, in TeX, TeX is very good. It's kind of inserted inside LaTeX, so you will have the same fonts, the same commands, and everything will be in the same style. For example, to get graphics with LaTeX fonts, I don't know, it's pretty hard. In Matplotlib, you can say Matplotlib that you want TeX fonts, but TeX should be installed on your computer. Probably some of you tried to do this. Those of you who were in our Python course definitely tried it. And yeah, small TeX graphics can be used in various templates. For example, if you will make your resume as the final task, you will probably use some elements of graphics. And I should tell you about my personal experience with TeX. On my fourth grade of bachelor degree, we had numerical methods. This course was told by old-style mathematician who smoked Belamor Canal, and he asked whether we could put his lectures in the TeX files so he could print them and have them in the nice format. And us, a group of students, we took these handwritten lectures and put it into LaTeX, and I used TeX graphics to draw these beautiful kind of abstract mathematical drawings. So for example, if you want to create a math textbook, you will probably use TeX graphics because it's very clean, nice, understandable, and yeah, very nice. Here we have the first example of more complex TeX graphics, not the inline figure, but bigger graphics. You can see that we put it inside environment TeX picture. So we have begin document, end document, and inside it we have TeX picture. We started with begin TeX picture and end TeX picture. And inside this picture we have green circle, as you can see, and also additionally we have just an orange circle as part of inline graphics. Also, to use TeX, we need to kind of include the package TeX in our environment. To work with colors, we need color and Xcolor. And later we will have some other additional packages that are needed for TeX graphics. Okay, we have our first task. Please, we will have this part of the presentation in the chat. Please follow one of these two links and look at the examples how you can use TeX graphics. Okay, I hope you all admired the beauty of TeX graphics. Okay, let's continue. We won't go that deep. We will cover basic structures. Okay, let's look at the simplest example of TeX picture, and I will tell you about path command. Path is kind of a global class, yeah, right? Global name for all TeX objects. So actually, other commands that we will cover today, they are kind of part of path command, but they are widely used, so they have their own name. But is it here? No, it's not here yet. So it is the simplest path that not the simplest, but one of the passes that we can write. You can see that we give 3 dots in the pass, and probably you understand that what is these numbers in parentheses. Coordinates, right, these are coordinates of the dots. We have 3 dots on the square mesh, kind of. Yeah, these are coordinates. Default units for the coordinates are centimeters. However, you can tell LaTeX to use other units of measures that you know, but default is centimeters. And path is kind of global instance. It cannot draw anything. If you want to draw, you need to add additional options. Okay, and here we have the first huge example of different variants how to draw something. And on this example, I will try to show you in overleaf how it works. I hope it will go well. So let's open overleaf. It is here. I believe you can see, right? You can see the screen. What I will do? Oh, somehow we don't. Is it okay that we do not have this example in overleaf? Should it be here or not? Is it exercise 1 or no? I want the code from the slide. Yeah, the whole.
Just a moment.
Okay, let's wait a little bit. Can we copy from the slide?
Yeah, but you want the whole?
Probably just the picture. Oh, okay. Okay, I have the code from the slide inside overleaf. Okay. I will comment out. So I believe the best way to study some code is to comment out several parts and see what will happen, right? I believe you all know the keyboard combination to comment big pieces of code. You need to select them and press Ctrl/ or Command/. It is a fast way to comment some parts of the code. Let's see what's happening in the first line. So, as you can see, we don't have TeX picture here, we just have TeX inline graphics. We have 2 horizontal lines. Between these horizontal lines, we asked TeX to draw, not to draw, but to have a path, including 3 points. And as you can see, the lines are separated one from each other. It means that paths exist, so this picture exists. We just didn't ask TeX to draw anything. So it is kind of abstract dots without any visual representation. Why would we need this? I don't know. It's kind of abstract instance, so you know what is path. In the next part, what we have almost the same code, but instead of path, we ask TeX the command draw. What this command does? It draws the lines connecting these dots that we have stated. So we have 3 dots, 2 lines, and you can see here 2 lines. Is it clear? Understandable? Right? Okay. What's the difference in the third part? In the third part, instead of draw, we ask TeX to fill the space. It fills it with default black color, and also for the space to be, I don't know how to say it in English, closed probably, we add the keyword cycle after stating these 3 dots. It means that we want the space to be circular. Or I believe we could just add the same first point at the end, so the path will also be circular. Okay, in the fourth, number 4, we have more specification about which color we want this triangle to be. So we use the command fill draw. After this command, in square brackets, we usually give some options to the LaTeX, and in TeX, in square brackets, we also give options. What we want from this figure. We want to fill this path with the color. The color is defined in the way that Anton showed you yesterday, but I will repeat. We have the special syntaxes for defining colors. What is this color? It is 20% green, and the rest is white. So it's kind of 20% green, 80% white, right? So it's light green. Draw is a special parameter to tell which color we want to see the border. So the border in this case is much darker. It contains 40% of green, other black. So it is almost black, and we cannot see the difference on the screen right now. Is it clear? So in LaTeX, you can use kind of simple colors. If you want to use other, or you can use the syntaxes for defining colors. If you want to use other color names, you need to define them or import some packages that will contain, for example, HTML colors if you want them. Okay, let's go further. In the number 5. What do we have in the number 5? In the number 5, we have the same collection of the points. We use the command draw, and also in this draw command, we give parameters in the square brackets. These parameters define properties of the line that will connect all these dots. First of all, this line should be an arrow. An arrow points to the direction to the right. If I believe we will change the direction of this arrow, it will go the other way. Other parameter of the line that it should be very thick. So the parameters, I believe, are very thick, kind of normal, and thin and very thin. And it also should be dotted. Probably you know this parameter of the line. Other parameter can be dashed. So if we change it, for example, for dashed, and very thin, you probably won't be able to see it. Let's try it. No, it is still visible. So in LaTeX, if you want to give several parameters in square brackets, you separate them by commas and just give new options that are different from default options. Let's look at the last 2 parts. So in the number 6, we just draw the circle. We have already seen how to draw a circle. We give the coordinates for the center, the shape circle, and the size of the circle. And we can also draw in a very similar way the rectangle. For the size of the rectangle, we should give 2 numbers because rectangle is not symmetrical. It can be different in vertical and horizontal kind of directions. Yeah. Was it clear with these examples? Okay. Let's go back to the presentation. No, предпоследняя. Okay. Should I make it full screen Control L probably. No. Okay, thank you. Okay, so on the bottom of the slide, you can see what I wanted to tell to you about path. So kind of when we use draw, it initially was path with a property draw, but it is very popular command, so it has its own kind of name, but it is a part of this abstract path instance. The same with fill and so on. So these commands are interchangeable. Okay, let's go further. The next thing that we will talk about is the command node. This command lets you to create some text inside some figure. So for me, it's very similar to autofigures in Word, inside which you can add some text and connect them and so on. The nodes are very similar. So to create node, we use a command node. In the square brackets, we give the parameters how this node should appear. In our case, for example, it has rounded corners. Then we tell at which coordinate we want this node to exist. In this case, the coordinates doesn't matter. If you draw a complex node structure, for example, some block scheme, you will arrange the nodes as you wish. And this sign is just to tell you that we have a new line, so it is kind of not needed in your code. And in the curly braces, right, we have the text that we want to put inside the node. Yeah, this is all. Is it clear about? Okay. And also node is also kind of a part of the giant abstract path command. We will use, probably you will use nodes to create graphs. So block schemes, we have an example of a graph on the next slide, and we will also research it using overleaf, right? Let me show it to you. I forgot the file name. Live node, thank you. So I have a separate text file, I compile it. It should show you this structure. Okay, here we have the code for this TeX picture. Let's comment out draw commands and compile it without this comment. Okay, so what do we have? In the TeX picture, after the command TeX picture, we have some parameters that will be applied throughout the whole TeX picture. These parameters are again in square brackets, and in these parameters we tell that we want to fill everything with light blue. So this is 20% blue, 80% white. And as you can see, in other commands, in square brackets, we just have the word fill. And by default, all these figures are filled with light blue color. If we will remove this property from the TeX picture, default filling color will be black, and we will not see anything. Yeah. You want to do the same as me, right? Can we send this code somehow into the chat, probably as a TeX picture just? No? Can you do this, please?
Yeah, of course.
Yay, thank you. Okay. So let's see what we have in the giant command path. So the first command in the TeX picture is path. In this path, we create a series of nodes. As you can see here, we create 3 nodes. So this path consists of 3 points. Each of the points is a node. Each node have, let's see, this is the first node. Each node has coordinates where to place it. It has designation that it is a node. Also, each node has a name. Name goes inside parentheses after the word node. When we give node names, we can refer to them later we don't need to remember all the coordinates. We just kind of label the nodes and usernames. Then in square brackets again, we have the parameters for the nodes. We have 2 rectangular nodes and 1 circular. We rotated some of the rectangular nodes. It is also a part of kind of properties, how to draw it. And inside curly braces, we have text that should be placed inside the node. So we have the same syntaxes for all 3 nodes. We have node B, node C, rectangular, and node D, also rectangular. Please take your time. 3 different nodes with different properties, with 3 different names. Then, we can imagine that these nodes are part of your pipeline. You want to draw your pipeline in your LaTeX thesis. You will put some text inside the nodes, and then you need to connect the nodes with arrows, saying in which order you did your steps. We need to draw several lines. We have 3 lines and 3 commands to draw them. As you can see, we use a command draw. In the square brackets, we tell the parameters for the lines. For example, the first set of lines in this piece of code. We have a thick line without any color, so this line is black. And this line connects node B with node C, and then with the kind of right part of the node D. Not right, but left, right? So west is a kind of on the left. You use dashes, horizontal lines, to tell that you want to connect these 2 nodes. And also when you connect your nodes, you can tell exactly where you want to put the line on the node, kind of. I believe you got me, right? We can, for example, try to change the west to the north, for example, and see what will happen. So D is a rectangular, another rectangle, and now the line will be very ugly. Will it work? Yes, so now this second line goes to the north, to the upper part of the rectangle. It goes through the node, not very beautiful. So you can see that the second line is red. This line is an arrow. And also, we have a special designation how this line should go. Instead of 2 horizontal dashes, instead of straight line, we have first vertical dash, then dash. It means that line should go first vertically and then horizontally in a rectangular style, connect 2 dots, not straightforwardly, but in this path, kind of Manhattan logic. And the third line, it is the most difficult. It is blue. It has arrows on the both ends. And you can see that it connects node D, not B, and node D. And between these 2 nodes, we have this line with controls. These controls kind of help to curve the line in the manner that we want. So you can play with these numbers and see that these are kind of special dots that help you control where this line will curve if you want to beautify your graph. Okay, let's go further. I believe all you have this code and you can play with it on your own. Yeah, I learned it. Okay, so what additional do we have on the slide? On the slide, we have learned that we can label the nodes, and then we can refer to these nodes by their names. We can state where we want to connect, where exactly we want to connect the nodes. Yeah, and that's all. I already told you about the strict with vertical then horizontal. So instead of straight, we can do it in a rectangular manner. So we can draw this triangle, just defining 2 dots, 2 diagonal dots. First, we connect them in a straight line, then we connect them in a Manhattan style. Also, about curves. If we want to connect two dots with curves, we need to state at which angle each curve, I don't know how to say it. So we need to state the derivative kind of for this curve at each point. So the angle at which this curve flows in and flows out from the point. And these angles are measured kind of in a trigonometry matter. So to the right is 0 degrees, and counterclockwise you measure the angles at which curve goes in and goes out from the point. Is it understandable? Okay. Other sweet tricks. So the first trick is that you can easily draw a coordinate mesh. You need to use command draw with parameters help lines, coordinates of the grid, and it will fill the grid with help lines. The second part is that we can use 3D coordinates. If we give the third coordinate, LaTeX will automatically understand that we can use 3D kind of 3D graphics. And also we can use polar coordinates. If we give our coordinates in this form with a column in the middle, it understands that it is kind of the distance. The second parameter is the distance from the center, and first parameter is the angle. Okay, let's go further. This part is about drawing some paths, and probably you had informatics class in your early school when you needed to manipulate some, I don't know, machine, robot. Did you have these tasks where you should write some algorithm for the robot that goes on the square mesh and needs to draw Christmas tree, for example? Yeah, I had a lot because we had informatics class at the second grade somehow. I don't know why. So this is kind of the stuff. So instead of giving absolute coordinates at every time, you can give increment that differs from the previous coordinate. You give this increment either with double plus sign or with a plus sign. The difference between these two methods, as you can read it here, so if you use double plus, every time you renew starting point. So each increment is individual. In the second case, when we use only one plus sign, kind of increment counts only from the first coordinate. So please compare these numbers. So these increments are independent. These increments are kind of summing up till the end. Probably almost the last part before the task, right? So we have a special library calc in LaTeX, and this library can help us to kind of calculate the coordinates, for example, on the straight line. So we want to draw such a thing. We first draw help lines coordinate mesh with the first command. Then we draw the line that connects 2 points, 0, 1 and 3, 2. And the next command for each I, it's very kind of similar to something Pythonish style. So for each number, in some list that we define by our hand, we want to place node, and the coordinates of this node are defined kind of 20% distance from the first point to the second point. So this whole interval is kind of 1, and I want, for example, the second point will be on the distance of 20% of this interval. And to do this stuff, you need a special library calc, and you can place these points. Yeah. Also, very complex example. We will not go into details, but if you have a set of complex curves and you want to probably mark intersections or just find these intersections, there is a library intersections that can calculate where lines meet on your drawing. So you don't need to calculate these points manually. LaTeX can do this for you. Yeah, almost last part. Oh, about graphs. I should again do kind of live coding, right? Or not? I don't know. Do you want me to show it? Yeah. Probably, can we also send it? Can I send it? Or you need to look into the source? Okay. Okay. Let's compile it. So you have the source code for this picture. Let's look at this picture. First of all, what we see at the start of this picture. We see a lot of properties for this picture. So at the start of the picture, we set the style for the whole picture. How we set it? We want to have two types of nodes in our graph. The first type is called place, just kind of any name that you want. And place nodes, they have a circle shape, they are bluish with some graphical properties. And we also have the second style, transition. These nodes have other properties. And as you can see, when we define nodes, in these lines we define nodes, in the square brackets, we don't have many styles, we just have one word, either place style or transition style. So we have two types of nodes, blue and gray, and they are of two styles, place and transition, that we defined at the start of the picture. So we define several nodes. How we define the node? We use a command node, then the style, or we can just write it manually with which color to fill, which color the border, shape, size, and so on. Then we have the name of the node. In this case, the name will be of two words. In the previous parts, we have the name with only one letter. Now we have longer name. And then we have the text that should be printed inside the node. So it's pretty simple. Also, about the location of the nodes. You can see this first node is just placed somewhere on the picture. Probably it is placed at 0, 0, right? At the default location. And other nodes are placed relatively to the first node. For example, the node my center is placed below of node U. So we have node U as the first one. Let me do this. This code just gives us two nodes. And in this example, we don't use any absolute coordinates, any numbers. We just use the special keywords below of, right of, left of, and so on. You can use them to place your nodes. And also we have lines that connect these nodes. I believe it is pretty similar to the previous example, right? So we have two arrows. To draw an arrow, we define two nodes that should be connected. In this example, we connect two pairs of nodes. And the second line is a curve. So for this curve, we set angles, which will be used to approximate this curve connector. Is it clear? Do you have any questions? Yes, I believe it is clear. Very good. Okay. I don't remember how many slides do we have left. Also pay attention, please, that these special keywords that define location are written in kind of one-word style. So to escape spaces, we use equality sign to kind of have this keyword in one word. So LaTeX will, I don't know how to say it. So spaces are special, and this is kind of one word. Okay, this is a very complex example. You should just know that you can do some complicated stuff, complicated graphs. You can do it if you want. And the final, I believe, part is about trees. Tree is also a special structure in LaTeX. If you will need to do such a picture, you can use special kind of tree commands. In these commands, we first set the kind of node TeX, and then relative to this node, we set children nodes. And you can see that we set them with keyword child. And in this simple piece of code, you can get such kind of rather complex picture. Also in this picture, styles are set also at the beginning of this picture. Yeah, we use node and child. Sibling distance is a special parameter when you use keywords node and child. It helps you to separate the nodes in your tree. And we have the task. We have level 1 task. You should draw this simple block scheme, simple graph structure, or as a second level, more complex structure with more text. Please start it. We will help you.
The another difference between level 1 and level 2 is in subtext. In level 1, you can use absolute coordinate. You can just put them, for example, in position 1 and 2, and so on. And in level 2 task, you can't use absolute coordinate. You need to make this coordinate level, relative. And about this stuff, we don't know how to do it yet. Sorry, I just moved this task from the below to this part. So you can try to do this part. If you can Google it, but we will see it later. Sorry for this chronotype problem. But the main difference is relative task, nodes or absolute nodes. please, if you have questions, ask us these questions.
Okay, dear students, I hope that all of you enjoyed drawing simple graphs with TeX. We will have small last part about TeX, then you will go to the break. Let's continue. Let's continue. Okay, the last part. Why probably you will use TeX? If you will do LaTeX documents, you will probably use TeX as part of kind of your whole document, not to draw the separate picture, but to incorporate some graphics, some arrows, some lines, shapes inside your document. And I will show you several examples of how you can do this. Let's go. First example is for use, for example, in your resume. As I understand, Anton probably uses. Is it? So this is the graphics that Anton uses. We have two examples. Border outside of the word and this small pie chart. This code is for this border. What is going on in this code? Let's see. First of all, this command is to kind of create your own function in LaTeX. To create new command, Anton will tell you about it later. However, basically you can see that this command has a name. It has one argument, and after it you have the body of the command. In this command, we tell that we want inline TeX graphics. We want to draw a node with several visual characteristics, and in curly braces we place the text that we want to put inside the node. In this case, we use kind of the first argument. The designation is the same as in Bash scripting, Linux scripting, right? So this means to place the first argument of this command in the node that has such visual characteristics, and you once put this command in your LaTeX script, and then you use it very simply. You place the name of the command, word that you want to put inside the border. It is printed in this nice manner. Let's go to the second example. The second example is about these mini pie charts. This is also a special function. This function is kind of harder than the previous one. In this function, we also have one argument, and this argument says which part of the circle to fill, how many tenths part of the circle to fill. You can see in the usage that we use two pie charts, one with 20%, one with 70%, 20-70, and you can see in the code where we use this first argument. We use it to fill the sector with designated number of degrees, so argument multiplied by 1/10 of the full circle. And you once define this command, and then you can simply use it in your resume. Probably you will have such commands in your template that you will use for the final task. Let's go further. Is it clear with these examples? Let's go further. The next example is how Anton put the magic hat in the corner of the presentation, because this presentation is made with LaTeX. Let's look at the command. It is pretty hard, probably. Let me look at it. So, what we have here? We have an environment TeX picture. We tell LaTeX that we want to put this picture in the northeast part of the current page. It means in the up right corner. Remember, picture means that we will kind of remember this command for future use. Remember how we placed this head. Overlay means that this head kind of goes above all the information on the slide. What we have inside this picture? We first define the node with the name and m. We will use this node later for our future graphics. And we also use the command include graphics. It means that inside this TeX picture, we want to put the picture from PNG file with width 1 centimeter. Okay, so this command will place the picture of the head in the upper right corner of the slide. Yes, this is the place where to put the picture, and also you can see that in the this is the place to put the picture. Next part is about how to draw the line to this picture. You remembered that we included in the picture a special node and M that we use to draw the arrow. When Anton have written this line of text, inside this line of text, he also placed a small invisible node that he called start M. So kind of this piece of text is produced with this line of code with invisible TeX graphics. And then to draw this line, Anton used command draw, and he used two nodes, start M and end M. End M node was in head definition on the previous slide. Yeah, this is a calculation to put the start of an arrow a little bit to the right from the text. Yeah, very beautiful. Do you have any additional comments about this piece of code?
What do you think? How I place the arrow to this arrow from the previous slide?
But then you need to guess the position, kind of guess the position of the curve. So actually, to define this curve, Anton just told that I want angle 0 here and angle 180 here. LaTeX created spline line, kind of square curve, right? So we just have this abstract curve. You suggest just to guess, right? Just to guess the coordinates of this point. Do we have other more elegant solutions? You remember that we had intersection something package that can calculate where two lines intersect. So Anton actually created the second line, calculated where it can intersect the first line, and then told LaTeX to stop drawing this line exactly at this point, right? So it was all automatic without any guessing, but you should know about possibilities of the LaTeX to do this, right? Okay, this example that LaTeX is only for use in academic area is wrong. How to create this picture? Let's analyze this text picture code. So first of all, we have a node with initial text that LaTeX is only for use in academic area. Then uncover is a special command for the beamer, for the presentation. So you see that this wrong picture, it appears only after kind of on the second slide. So uncover is a command for that. And then we want to uncover kind of another piece of TeX graphics with wrong node, rotated, colored, in huge font. That's all. Yeah, and we have break right now, right? This is all for my part. Thank you for your attention. See you tomorrow also on the next lecture.
Well, right now we will have a 12 minutes break until 70:40, 12 minutes break, and then we will return, make the exercise of TeX. So the TeX is not over, we have another exercise, and after we do it. We will go to the next part. It's more slides, but we will not stop at most of the slides. We'll just lead them away, so it will be more or less quicker. Now, 11 minutes break. Guys, let's start. So some of you gone. Okay, let's start. First, technical question. Who forget to send the in-class task from lesson 1 or lesson 2 to Canvas? Who forget to do it? Please do it now. You can do it because then we will have another task, so you will have time. Please do it. And what? In-class tasks, we submit the result of your classwork to Canvas. So, yeah. There is an assignment for each day. And for today, the assignment will be created soon. So when the lecture will be ended, we remind you and please submit the assignment of current class at the end of this lecture. If you forget to submit work from previous tasks, from previous days, please open Canvas and make it now, because about 1/4 part of you don't submit this task. We will wait for a minute to you to do it, and then we will continue to the. Don't forget to submit the task from previous day to Canvas. You need to submit the PDF files to Canvas. Don't forget. Okay, a minute for waiting and we'll continue. Minute for you to submit. Okay, let's continue. And I want to highlight a very important thing about how to think in LaTeX way, but not in Microsoft Word way. These ideas must be clear for you if you have a programming experience. Please raise your hand who have any programming experience, who ever program. Most of you program. So you know this idea of divide one part program from another part, so you don't have this mesh of codes that do everything. You divide in one part, you make some output, in other part you have some calculation, and so on and so forth. You know this idea, yeah? Guys, yeah, you know. So what I want to highlight is the same idea is in LaTeX and in TeX. It's very common that when you have some ugly and not understandable backend, when you have to do some magic stuff, because that's why I use my head now. You have to do some magic stuff and you don't want to look deep into it. Let's say backend, and the developer as the person who creates some library and a nice and clear UX for users. And TeX is the first and perfect example for this. Let's look at this closely for some of these examples. Okay, for example, for creating notes, if we omit such kind of stuff, you use just note, and the text. If you use graphs, you don't want to, when you're writing the graph like this, you think that you want your arrow to be not to exact pixel, but you want this arrow to go from one node to another node. And TeX allow you exactly the same. Not to put the node from, for example, 01 to 75, but from one node to another node. And this is syntax supported. If you run graph, usually you don't want to understand where the absolute coordinates of the graph. You think that you have one vertical vertex, another vertex, and are they connected or not? And TeX give you the UX that give you the opportunity. Just connect one node to another node. This is all you want. This monstrous example, it's really hard to understand, but every hard part is just the beginning. Only this part is hard. And then we have a pretty simple stuff. We go from nowhere to assign integer non-terminal to here, and then we go to P1, so there, and so on, so forth. We go from P1 to P4, and so on. So this syntax is pretty simple. The hard stuff is just the beginning. And the hard stuff is this, so yeah, you need to somehow to get this hard header, but then the syntax is pretty simple. You have just node have a child, and you write that this node has a child. This child has another child, and you write that this child has another child, and another child. So the syntax of drawing is really simple and really straightforward. These examples. This part is really annoying, but the syntax you get is just one comment, and when you write what you want. Again, this syntax is much more awful, but again, the UX, the thing you will use is just one comment with one number. It's really simple. Yeah. And here you see that there is absolute integration with Beamer. So why I highlight it? Because every time we use TeX, we need to understand, in one hand, obviously we have such annoying thing as writing graphics without just drawing it from one hand to another. So it's a very deep cons. But what we have on the other hand, we want a clear syntax, because for graphs, all you need to do is to understand how one vertex connects to another. You don't want to see this, you don't want to calculate where to put them. You have an option to use some example from the internet and modify it in your way, because when I put something like this, obviously the names of these nodes are mine. Obviously, only I want to draw this picture. But the graphs, this one, is come from the internet. I don't need to create it by myself. I just may use something that I find and modify, because the syntax is clear. And you can use such simple syntax as there to understand. And obviously you can use the all power of tech integration. You can use comments, you can use fonts, you can use pictures. All of this come with TeX. And so when you use such attributary picture, TeX is not your way. But when you use graphs, when you use LaTeX, TeX is the thing that you may want to understand. And the two tasks for you for now is just for it. So I need to clarify this task because it's not really understandable from the slide. Level 1 have two subtasks. Firstly, you have such kind of code, and Peter sent these slides for you. You have such kind of code. Well, it's not the whole code, it's there is code from preamble, and there is code you need to put after begin document, as it's mentioned in the commentary. So firstly, please, after you finish, copy this code for your document, create a new document, and check that everything will compile for you. And secondly, well, we have a nice syntax with about 6 parameters, and it's dense, but let's imagine that you copy this code from one template and don't understand what this parameters is. So your task for this subtask is to understand what is the first parameter, what is the second, what is third, and so on and so forth. Just play it. For example, change the XX to all letter and see what's difference. Change the blue to red and see what difference. And as a result, create a enumeration. Then you say that the first parameter is on, the second parameter is so, and so on. The second subtask, go to this website and create your own mind map. It is useful to understand that creating mind maps is a pretty hard stuff, but all the hardness is hiding for you. Everything you will have is just a clear, dense syntax. So this is why please go, try to use this library and see that you often have this dense syntax that hide all the hardness from you. And for level 2, it's much more complex. I think it's maybe level 2 with star. Imagine that you want to produce such kind of circle. I copy it from Alter CV. But you don't want to use the whole template, you want to put it to your template, your own template. And then you erase it from the original template, go make it your own template and have a tag file like this. And don't be afraid, Peter sent you this tag file too. But this tag file produces some errors. Obviously, when you erase, you forget something. So try to compile it, see what errors are, and try to Google how to remove these errors, what you need to compile, and make this document full, make it compilable. So these 2 levels, they are different for now. Start with level 1 and then go to level 2. Is the task clear? Okay, has you any questions for this task? No, then let's start, please. Try to play with this code, and then go to mind maps, and for level 2, try to compile the document that is a bit broken. This exercise was sent at you before the break, so if you are waiting for new sending, it's already in Telegram chat. It's already there. So, who already compiled this stuff? Who already compiled this stuff? Yeah, for this first subtask is pretty simple, just copy, and everything before the last line is before begin document, and the last line it's the after begin document. Just compile it and see that it's all compiled, and then play to understand what the parameters is. Your major goal here is to understand what parameter, what the first parameter is, what the second parameter is, what the third parameter is, and so on. Because, well, this was copied from another template, and they has no documentation. Obviously, we can see this we can understand the documentation, but there is no documentation from the box. Don't hesitate the second task to make the second task after library mind maps. Don't hesitate to make the level 2 task. There will be errors, but I left only the easy Googled level errors. If the error are hard to Google, I just make it for you. So the level 2 task, it's monstrous to view, but it's simple to done. So don't change this stuff. This stuff will remain the same. Don't change this number, don't change anything there. Change only these parameters. First, second, third, fifth. Okay, there are 6 parameters, so change this and see what happens. Only this. It must be pretty easy stuff. After this, try to make a mind map. And after this, try to make the level 2. Again, it's monstrous to look at, but it's rather simple to Google. All errors are Googled rather simple. In level 2, you will find that you lack of some colors, and we see how to define colors in previous lecture about Beamer. So the tag file for level 2, this file that you need to fix errors. This file, obviously you can copy it from this, but we think it will be too cruel. So this whole tag file is uploaded to the Telegram chat before the break. So you can copy it either as entire file to overleaf or just open this as text file and copy it as a text file. Please don't copy it from the presentation. It will be, you don't need it. You can use just tag files that we uploaded. Okay, who completely make level 1? Who made both the task of level 1? Okay, does any one of you need more time? Who need more time? Please raise your hand. Well, okay, there are some people, so we will wait for another, I think, 2 minutes. And meanwhile, you can complete level 2. Level 2 sounds like monstrous. It will not be compiled, you will be afraid of it. But the point of this task not to be afraid of errors and try to Google how to fix them. So please come to level 2 and it will be essential for your usual life because obviously we'll have some errors when you use LaTeX. Okay, level 1, do you need more time? We'll slowly understand the level 2 and I hope that it will be enough time for you to make the level 1. Who already done the level 2? I see several people who already done level 2. Okay, a bunch of you. It's really great. I am proud of you. And Peter, can you give this man a sheet? Выдайте этому человеку щит. Стикеры раздай, пожалуйста, людям, которые сделали level 2. Они прям молодцы, я очень доволен. Shield, not sheet, shield. Who done level 2, please? Raise your hand. Опять, вот смотри, вон они, вон же они. This is the heroes who level... По одному стикеру. Возьми их все и просто раздать, что тебе их считать. Я хочу лайфкодить. Okay, let's see. Спасибо, Петя. Let's see, we need to upload file. This one. We uploaded. The man who did level 2, you are the great one. So let's try make it in additional way. Okay, the first thing that we see is a defined color accent. So what you need is to define color. Define color accent. And how to define, don't remember, but I think it's something like this, RGB. And okay, some color, we define some color. I hope so. Yeah, and this is so, well, no, okay. It compiled, but still it has some errors. Let's see, errors. Well, unknown error type kind star. So I don't know what to do, let's just Google it. And we have Stack Exchange. Let's see the answers. You need use library errors because this is just what Stack Exchange tell you what to do, and as a programmer you never can obey Stack Exchange. It's the programmer's credo. So let's add this library and see will the errors will be there as errors. Okay, it's still compiled but still has errors. It's a known K, what it is, I don't know what TeX emphasis. Let's see what can be. Okay, that's about color. We see that this is something about color. And let's make what this color is. Let's understand what the color is. If we define color like this, will it help us? So we see something about colors and let's define the color. Yeah, and now we have a known color body. We'll still make it the same because we are too lazy. And recompile, and the last error that some method requires package hyperref. It's pretty straightforward. Let's just edit it. Package hyperref. And yeah, it's compiled. It's compiled and no errors, just one warning. We will ignore the warning because it's just warning. So obviously, when you try to compile this document, you will have some errors, but in some cases they are pretty hard to understand. But in most cases, you just need to Google it or to ask ChatGPT, and it will tell you what to do. So don't be afraid of errors. And well, we have about 40 minutes for more than a half lecture, but as I tell, it will not be very long because most of the slides are just for references. We'll go to user level typography, what typography you need as users. And the core typography as code in LaTeX and TeX will be the next time. Okay, first text positions. Oh, this is head slide, so I will use my head, sorry. You can use something like this to add indents and to make them to make position of text somewhere. You can use text position package and understand how it works if you want. Also, you can use text position. You can use TeX. So in this slide, hello is in the upper left, upper right corner, and the word is in the center. All of this done by TeX. You can use it and understand how it works. You can see it. And this all, okay. Sometimes you need rules. It's called rules, and we have hash rule, we have var rule, and we have just a black square. please use it when you want. We already have some tasks when you need to use such rule, but it is just one of the more general rule command. We have some stuff called leaders. Well, I never saw this term before I read the Donald Knuth textbook. So the leaders is basically the stuff you use in the table of content. But leaders is not just about dots. You can use practically every symbol for leaders. For example, you can make the slide that will be based just a tech word, tech, and it can be done with leaders. You can use some geometry package, again, magic, you don't think about it. If you're too lazy and you just want to add typography, check typography, you can use Prism package. And you can use fonts. You can use fonts. Well, this will be the only one meaningful part of this whole presentation. So we already know how to use font families. We already know that you can use, for example, italic or bold, that you can use typesettings. You may use fonts with different size, but this is all what you can do. It's in one font. So one designer says that my font, when you shape it to italic, it will be something, and then I shape it to bold, it will be something else. There are more than one font in the world. We have multiple words, and the most, it's hard to classify them, but most usable classification is serif, sans serif, type-wrapped, and everything else, because we can classify all. So serif is with this stuff, you see this stuff. Sans serif without this stuff, so no point there, no point there. A typewriter is for writing comments, because every symbol has the single length, and everything else is for everything else. And yeah, we will stack at this slide, because then it will be just for reference, everything else. You may remember that I told that there are PDF LaTeX and LaTeX. Do you remember what's the main difference between these two stuff? PDF LaTeX and LaTeX. What's the difference? Yeah? Yeah. LaTeX use the system fonts, and PDF LaTeX use the stuff called meta fonts. It's for historical reasons. TeX and PDF LaTeX was created back in the 90s, and there was no such thing as standard fonts back then. So the Donald Knuth, who created the TeX, he also creates the meta fonts. He also creates the type how to understand, how to create new meta font. He also creates this. But everyone else makes fonts in other ways. So now we have meta fonts and our standard system fonts. And there is several cases of how you can use something. Well, the first division is LaTeX and PDF LaTeX. The second division is, do you want to use font globally for entire document? You can change the whole font, the font for the whole document. For example, if you run a presentation and your organization has your company font, you can ask to use this font and everywhere. Or you can use the font just for one case. For example, you want to highlight one paragraph with another font to make it more visible. So this is the second division. And the third division is the font. Okay, the third division is different from PDF, LaTeX, and LaTeX. For LaTeX, it's simpler if the font is globally available or it's just local. Whoever work somehow with fonts of your system, whoever install any font, whoever add any font to your project, whoever finds this missing font, please raise your hand. Only a few of you, okay, so this will be new. Okay, fonts are just files with some extensions, and your system understands this is font, and if you install to one directory, system will see it as word file, as a system file, and if you add it to your project, it will be locally available. So that's all, only a file with some specific type. Okay, so for LaTeX, it's simpler. You can use Word system installed font or local installed font for global usage or for local usage. In PDF LaTeX, you mostly use the font including by using some package, and some package are available by default, change the font globally, and some package by default change the font locally. And then we have local want to add it locally or globally. So this is the division. LaTeX, PDF LaTeX, you want to use font globally for entire document. You want to use font locally for just a few words. For LaTeX, you want to use fonts that globally installed or locally installed. And for PDF LaTeX, you want to use packages that by default suppose global installation, and or package that by default suppose local installation. Everything else, I hope everything else will be just commentary of this slide. Yeah, maybe Peter, can you send these links? Okay, let's have a few minutes for you to see the fonts available in PDF LaTeX if you ever will have PDF LaTeX. You ever want to use PDF LaTeX, please go ahead, go to Telegram chat and try these websites and check on some fonts. By the way, obviously, it's the second time when I am happy that Skoltech is English-speaking university, because there are much more fonts for English and not for Russian, because everyone uses the font for English, you know. So let's go somewhere. There is text example, and there is usage. You can use package and style examples. So for PDF LaTeX, it's pretty straightforward. Just go somewhere, use package that tell you what to use, and go to styles. See, there is some interesting stuff. Okay, let's go further. And yeah, the very last stuff that you need to know when you use LaTeX, both PDF and LaTeX, that sometimes you ask it to make, for example, italic, but nothing happens. You sometimes want to make it bold and nothing happens, or you want to use it small caps. You maybe remember from the first lecture this small caps font and nothing happens. This is because that every shape that you change must be produced by designer of this font. And well, for standard shapes, for example, italic and bold, most of the fonts are produced. Most of the fonts have this shape, but still we have a lot of shape, and you will see it in the next slide. And if you go to logs, sometimes you will have a strange error like this. Obviously, a code there, but how to read it? So the first one is the encoding of how the font is encoded. It's the second one is font family. Then it's series, so bold, italic, bold, medium, tiny, and so on. Then it's shape and font size. And there are some common encoders and some common families. You can use it if you want. And there are a lot of not very common use shapes that are, because they're not common use, they're available not for all fonts. For example, you can use not only medium or bold, you can use semi-bold or thin font, or you can use thin font with italic, or semi-bold with caps and small caps. So such strange behaviors are not supposed for all fonts, but they are supposed for a few of them. Yeah. Let's go. So there is the foul font usage. We will quick from this to the end. And if you use PDF LaTeX, you will have some package. You will see you can load some package. You can use global fonts. If the package is for local usage, you still can use it locally to make something like this. And you can use this globally by making some external things that we will not see there. Just you know that all of the stuff can be made. You can use global fonts. You can use local font if it's changed files. So you can make something like this. Okay, you can make font usage with some comments. You can use for LaTeX, you can use fonts that was in PDF LaTeX, and you can use OTF and TTF fonts. You can use global font usage with a global font by something like this. You can use font with semi-infont. You can use something like this. For example, Georgia and Arial. Who knows the Arial font? Who knows the Arial font? Most of you know the Arial font because it's just a regular font of our word. You can use it in LaTeX. You can Georgia. You can use these commands. You can use locally font to change something locally. You can use default global changed and local available font by just add this path where to find this font. And by the way, this slide I will stop. When you use font locally, it's regular that you have some default font, for example, let's say regular. And for bold, you need to install another font because it's just another shape. For example, for italic, it will be Lato italic. And if you don't have this stuff, that you will not available to use anything about else than regular. And you can have some font commands. You can use this. You can use font locally, and you can find the font. It's easy. You see, it's really easy to find the font what you need. Well, practically not, but I hope some of you like this monstrous ham. There are some useful links for the fonts that are available in LaTeX, the fonts how you can identify the font by picture. There are some fonts with Cyrillic that is necessary for Russian speaker if you want some Cyrillic fonts. And you can use a lot of sites to select a font. There is a typography idea of font pairs, that one font is beautifully matched with another one, and if you want to go deeper for this, you can follow one of these sites. and they will be too quick, but the cell task just to orient on all this monstrous information. All you need is, Peter, I won't ask you to send this the last task. All you need is just to find between these all reference slides the and please send the TTV files, the font files, TTF files. All you need is to find in this slide how to use in LaTeX global installed font, for example, Times New Roman. Do you know Times New Roman font? Yeah, so it's installed, an overleaf it's installed, so you can use it. Just you need to find how see it in the presentation, find it in the presentation. It's and for level 2, try to upload some local fonts. For example, the fonts we sent you to Telegram, or you can find any other local font if you want. And for level 1, choose to change it globally, see the difference. For level 2, try to make it apply font just for a few words. So that's all. The main problem will be to find where the needed information is. Or ask ChatGPT, it can help you too. So let's come to the end. Well, level 1 is marked at this slide. So all you need to do is send main font, Georgia, Arial, or in our case, Times New Roman. If you add this exactly one line, and you will do what you want to do. And by the way, literature tag means that something like this, the two apostrophe will transform to this beautiful commas. If you don't use literature tag, then it will be still two apostrophes. And for level 2, you will need this slide. You will need to send a new font family, give path to this slide, to the font if there is any path. If it is in the root, you don't need this stuff. And you have the regular file, and for bold you can use another keyword. If you will have to use not bold but italic, again another keyword, and so on. Thanks. Okay. Are there any questions of how to use font in ideologically? Of course, it's hard to understand what comment is, but still. Okay, then what we have learned today? First part of our lecture was about TeX, and our main goal was to tell you that you can divide the stuff of how the global stuff of how something looking, and the local stuff of how you will and make the dense UX for your code. And it is available for you, it is available for some external developers. And this separation of how to use and what to show is the main idea of TeX and maybe in whole LaTeX. And then we go to typography, we add something about rules and leaders and text position, but then there was a lot of slides about fonts. We don't drive into these slides, but still they're available for you. And if you ever want to add your specific font to your specific project, you can use these slides as a reference. This is a reference. Tomorrow, we will tell about how TeX compile, how TeX sees this document, and we will see the part of TeX that the founder of it, Knut, tells that it is the most beautiful part of all system, and it will waiting us for tomorrow. And now, before end, I ask you to upload the PDF to Canvas, just not to forget. Please, there are a few people that forgot upload the task yesterday and the day before. So please upload all task results, all PDF to Canvas.